you so much, Stan. Bailey, you're up. You plug in here. All right, so next up we have Bailey Wang. Bailey is the founder of Prismax, a startup building the base layer for real-world robotics. So please welcome Bailey up to the stage. Thank you.
Very cool, thanks everyone. So my name is Bailey. As I said, I'm the founder of Prismax, and I've been a robotics researcher for quite a few years now, ever since I think about 2012, 2013, back when robotics were sort of in its prehistoric phase. So back then, robots were here. If you wanted a robot, you had to build a robot, and that meant every robot was different, and you had to have an enormous amount of hardware knowledge in order to be able to do these things. These are the robots from the DARPA Robotics Challenge, and the DRC was sort of a competition to build a robot that could complete a variety of DARPA-specified search and rescue tasks. So out of that competition, we got these crazy machines, some of which don't really look like humans, and of course the winner was a carefully engineered tool that was designed to when the competition was much else. So then comes 2015, 2016, 2017, we got a wave of really important innovation in robotics. We moved away from building these theoretically optimal systems into much better integrated systems that, while not perfect in anything, ended up being really generalizable and good at a lot of things. One of the things I worked on back at MIT was the mini cheetah robot, and the mini cheetah was instrumental in pushing forward this modern movement of electrified robots. So out of the mini cheetah and out of its successors, we got commercially viable hardware. In 2025, if you want a robot, you're kind of insane if you go build it from scratch. You can probably buy the machine you want, or if not, there are off-the-shelf building blocks like actuators that you can use to go build something which is pretty good for your application. But you see all of these robots and they're commercially available, but you probably have never really interacted with one outside of a demo or a research symposium. And the reason why this is the case is because while the hardware is robust, they have a lot of problems actually completing real-world tasks. For the past, I would say, 8 years coming, the industry has really been over-optimizing for highly dynamic locomotion, resulting in this bizarre case where humanoid robots can do a flip in, I think, every axis now. They can do a front flip, back flip, side flip, and barrel roll, but are unable to pick up your dishes and put them in the dishwasher with more than about 87% accuracy. I think like 93% if you use the same dish in the same kitchen, like 80-ish% if you use dishes in a different kitchen, and for things which aren't really dishes, the accuracy takes to like 40% or something absurd like that. So the next wave of robotics really isn't going to be building more dynamic robots or building hardware which is more force sense or building better motors. It's going to be figuring out how to take the stuff we already have and getting it to go do something which is useful in the wild. The only remaining problem in sort of like the hardware deep research space, I would say right now, is probably manipulation. Hands are an annoying problem because muscles are really good, but I would expect that to be solved in the next year or so. I think everyone's realizing that. So why here? Why am I here? Why am I at Edge City? Well, robotics is interesting because unlike language modeling, there's an opportunity for open source projects to become the industry leaders. Like for the first time in AI, open source can go become the state of the art. And why is that? So language modeling is like kind of annoying. It's kind of annoying because the models are huge. That means the training costs are very high. Like even with the DeepSeek team's optimization, it's still $5 million to go train a model, and that means you need a fair amount of capital, or you'll get like 1 or 2 shots in a very small project. The closed source companies have a 1.5 years, 2 years of head start, which is a somewhat unfortunate choice by the open source community to sort of ignore large-scale unsupervised training until ChatGPT came around. And because text models are so overdeveloped, being able to advance the needle there requires an enormous amount of technical coordination, and that's like something open source is sort of bad at. Like you get a lot of smart people when it comes to communicating and putting together all that talent to like make a big technical advance. It's kind of tricky. And finally, all text models are like the same. They're trained on some variation of a web crawl, and they differ in their post-training split. When you go look at the leaderboards and you interact with the models, like 1 through 5 are all pretty solid models, and it's really hard to stand out. Like even to Sam's point, DeepSeek R1 didn't create a new state of the art, it replicated and disclosed an existing state of the art. So robotics are different because the models are smaller and the difficulty is not designing a good model, it's being able to find the data and to coordinate the people that contribute that data to train the model. And that's where open source is good. There's a reason why for quite a while the news research models were at the top of, like, just straight up like unilaterally top of the leaderboard among all models for a variety of tasks. And that's because the metrics news pursues are extremely data heavy and required, especially at the time, a lot of manual labor to do the data curation. Robotics takes it one step further. It's not just about data curation. The data was never there in the first place. So being able to collect the right split of data is important. And because there isn't a good foundation scale de facto data set for robotics, the data split you pick for your robotics model, it really is strongly related to the personality of the model and what it can do. And by moving the data needle forwards, we can really move the models forwards. The open source model architectures we have now are probably good enough to really take us a while. Like, we're nowhere close to saturating the open sourse backbones like Python 5 and 2. And model architecture, I would say, has not been meaningful since the transformers, since GPT-2. Like, transformers are very good at what they do. All attention basically captures everything, it's brute force. And I think if there's any model architecture optimization, it will come in the form of inference speeds in like a year or two when we saturate the data and when we start to do things. And because the models are smaller, the training costs are a lot more tractable. We're talking like 50K, 100K per training run instead of 5 million to be able to move the needle. And that's the kind of thing where like decentralized projects are able to coordinate multiple $100,000 runs to be able to do that. So at PrismaX, we build I like to say we build everything but the robots to support robotics. We obviously build data and collect data, but behind that data flywheel, we also do teleoperation services where people can either provide robots or connect to robots that already exist in order to generate data and do real tasks. And all of that feeds into our model partners' models. They build better models, the models get deployed on a platform that speeds things up and it keeps the flywheel going. And owning this cycle is important. If you're just a model company and you didn't care about data, you will quickly find, as many model companies have, that there's nothing to train on. Like, the engineers are idling as they try to figure out how to scale the data teams. If you're just a data company with no models at all, you don't really know what the industry needs. Right? There are a lot of projects which will blindly collect data in some locality or the other, only to find that it's a very collapsed distribution and it's not what people need. By owning the flywheel, you get the feedback you need to be able to tune what data you need. The people building models can interact with the people collecting data, can put out new data games, new data requests to be able to keep the needle moving forwards. And that's important. That's important because I think, like a lot of you in this room, I'm sure, I'm frustrated by the centralization in models. And to me, the issue is a very practical one. It's not that like OpenAI dislikes your positioning or your opinion. It's that OpenAI is a $1 trillion class corporation, probably soon to be publicly traded, and are a big legal target if anything goes wrong. So they have to cater to this absurd minimum risk baseline, which ends up not really being what anyone wants. And open models don't have to do that. Those organizations are less of a target, and that allows people to actually build models which align with society's values, that align with the values of their creators. And by open sourcing the backbones, people who care about different things can go build models which are good at different tasks. And that's really important in keeping these models useful, keeping them aligned with what people actually want, and building a good business. Like, I'm sure some of you, if you've ever tried to get ChatGPT to be rude to someone, it's like basically impossible in 2025. The model is extremely polite because of legal reasons. But the open source text models, if you've ever played with them, are quite spicy, and there are a lot of people who prefer that kind of behavior. And it's going to be the same with models in the physical world. They're going to have different opinions about what's safe, what's appropriate to do, and people should be allowed to make that choice. Yeah, so thank you very much. You can follow our project at Prismax AI on X. And yeah, happy to be here. Happy to talk to people who are interested in moving the needle forwards and bringing solutions to the industry.